Here we have a new circuit, quite a bit more complicated. Two switches, a relay, fuse, and a light bulb. The first switch is used to turn on the relay. We've wired an extra set of contacts in which then keep the relay on. A latching relay. As you can see, once this switch closes, even for a split second, it turns on the relay. Then a contact on the relay bypasses the switch. It keeps applying power to the coil. So the relay will turn on and stay on. The second switch here interrupts power to the relay and causes it to turn off. So now we have a latching circuit with a trigger and a reset. Trigger the relay so the light turns on, and reset. For those of you in the elevator industry or entering the elevator industry, you can see how this could be used to call the elevator runs, and then when the elevator arrives it hits a switch and the elevator stops. Here we have our next electrical diagram for the sample you just saw. Battery, fuse. Here we've added a contact on relay R1 in parallel with the switch. This is called a latching circuit. What happens is when we close the switch, it turns on the relay. The relay closes this contact, which then bypasses the switch. So now there's nothing to turn the relay off. The relay will stay on. Once it's turned on, it holds itself on. This contact then would close as before and light the light. So what happens is we close the switch, the light turns on, the light stays on forever. So we let go of the switch. As in our sample, how we clear this, how we reset it so that the latching relay will let go, is to have another contact. We can put it here. We could have another switch which is normally closed. And by opening this switch, it will be like a reset. It will turn the relay off. So let's call this reset switch. So we turn on a switch, the relay turns on and stays on, and to reset the circuit we have to push this switch, which opens the circuit and it turns off.